Hello, in this video we'll be looking at circular motion, and we'll be looking particularly at a vertical circle. Okay, that is a type of circle where, for instance, it's a bit like the loop-de-loop in a roller coaster, when it goes right up and round in a big loop and you pass upside down. So here we have our circle. In fact, we'll model this upon a roller coaster ride. So we'll look at 2 points on the roller coaster ride. One of it is here is when you're at the bottom of the roller coaster ride, and the other case is when we're at the top. Okay, we'll start with case, so this will be called A at the bottom and B at the top. So we'll start by looking at what's happening at B at the bottom of the roller coaster ride, or the loop-de-loop as you're going round. So imagine that is the trolley, and there are people in there. Now as it's going round at the bottom, we'll think about what are the two forces. What are the two forces? Well, acting on the trolley. So we have in the trolley, we will have the weight of the trolley acting down like that, given its mass times gravity, mg, and we'll also have the reaction force as it's hitting it, so the force of it touching there, and this is, we'll put that as the center. Okay. Now, as it's circular motion, the acceleration, this body here, whether it's A or B or any other position, it'll be accelerating towards the center. So I can draw on here. That's not very good, actually. So we have here, it's accelerating towards the center like that. Now, from our the earlier video on circular motion, we had the formula, the circular motion representation of Newton's second law, which is the resultant force is equal its mass times the acceleration due to circular motion, which is v squared over r. So F equals mv squared over r. Now in this particular case here, the reaction force here, R, must be greater than the weight, mg, because it's accelerating towards the center. So the formula that we can write is simply R minus mg is equal to mv squared over r. And we'll just make sure we know what everything stands for, where v is the, let's assume it's going this direction, where v is the velocity of the trolley, and the mass of the trolley is m, and the radius there is little r. So that is the situation at the bottom. So we see that the reaction force there is greater than the weight, and the reaction force is what will be pushing on the trolley and on the people. Okay, so that's in position A. Now we're going to look what's happening at position B, and we'll probably all get it on this single screen here, this single page rather. So B, when it's come round all the way to B, we'll draw the forces on there again. Again, there will be the weight, the force of gravity, due to gravity, the weight mg acting down. But this time, the reaction force, R, will be acting the same direction. Now the acceleration is still towards the center, so this time we apply this equation, the resultant force equals mass times the acceleration due to circular motion. We will get R plus mg is equal to mv squared over r. So that is the equation relating to B, and previously this is the equation related to what's happening here, A. Now, interestingly, there will be, if you're going round in one of those roller coaster rides, some people report, or people do report, that they feel weightless. Of course, they're not exactly weightless, they just feel weightless. And they'll feel weightless when in fact, so to feel weightless, the condition is that the reaction force is equal to 0. This is the situation at B here. So when the reaction force pushing down is 0, the person will feel weightless. So therefore, that would give us mg equals mv squared over r. Okay, and then the m's can cancel out. Okay, and what we'll come up with is we'll find that, so they can cancel to give us that v squared over r is equal to g. So in any situation independent of mass, to feel weightless on a roller coaster ride, it is the velocity squared divided by the radius of the circle is equal to g, which is of course 9.8 meters second to minus 2.